talk about using those half-angle formulas to find the exact values of certain angle measurements. And these angle measurements are angles that can be written as an angle that we are familiar with divided by 2. So let me show you how we do this. We want to think about the sine of 15 degrees as an angle that's divided by 2. So you can think about this as, well, that's 30 degrees divided by 2 to give us 15 degrees. Well, what does that mean? That means that A, you see the A is replaced with 30. So we're going to use A is equal to 30 degrees in our formula. So here's the formula. Sine of alpha over 2 is equal to plus or minus the square root of 1 minus cosine of alpha over 2. We know alpha to be 30 degrees, so we replace that here and here. We can go ahead and simplify that, and that's going to end up being the sine of 15 degrees is equal to plus or minus 1 minus cosine of 30 degrees over 2. Now here we need to think about, is our sine going to be positive or negative? Think about the quadrant that 15 degrees is in. That's in our first quadrant, which means we'll use positive here because the sine in the first quadrant is positive. Now, what do we know about the cosine of 30 degrees? Hopefully you can tell me right away that that's the square root of 3 over 2. So our next step would look like this. Positive here and the square root of 3 over 2, replacing the cosine of 30 degrees. Our next step then would be to express the 1 so it has a common denominator, so we can combine these two fractions into one fraction. So this would become 2 over 2 minus the square root of 3 over 2. I can write this now as one fraction, 2 minus the square root of 3 over 2, and that's all divided by 2, and that's all under the radical. Okay, now multiply the numerator and the denominator by 2, and that's going to get rid of this little denominator here because these two things will divide out. And we end up with 2 minus the square root of 3 divided by 4, all under the radical. Almost done, only one step left. This is the same as the square root of 2 minus the square root of 3 divided by the square root of 4. So I can take that square root of 4 and make it into a 2 by just taking that square root of 4. And we would be finished at this point. And you may or may not have seen a radical within a radical before, but that's very common in these half-angle formulas, right? So we have one of our 3 pieces. The other 2 work just the same way. So we start by thinking about what would this value have to be divided by 2 to get this 157.5. And of course, we find that by just multiplying that 157.5 by 2, and we end up with 315 degrees. So A here is 315 degrees. So we're going to use our formula, cosine of alpha over 2 is equal to plus or minus 1 plus cosine of alpha over 2. We replace our alpha with 315 degrees and 315 degrees. We simplify the 315 degrees divided by 2, and we end up with cosine of 157.5 degrees is equal to plus or minus the square root of 1 plus the cosine of 315 degrees over 2. There's two things that we want to do in this next step. We want to determine the sine. All right, and so we think the cosine of 157.5 degrees. Well, 157.5 degrees is in which quadrant? That's going to be in our second quadrant. So that means our cosine in the second quadrant will be negative. We will use a negative sign for this computation. Now the cosine of 315 degrees, that's going to be the square root of 2 over 2. So we can replace this whole thing, cosine of 315 degrees, with the square root of 2 over 2, and we will identify this as being negative. So we end up with something that looks like this. Negative the square root of 1 plus the square root of 2 over 2 over 2. Get a common denominator here. This is going to be 2 over 2. All right, I'm keeping that negative and the radical the whole way. let's combine these two fractions into a single fraction. We would have 2 plus the square root of 2 over 2, and that whole thing divided by 2, and that whole thing under the radical, and that whole thing negative. All right, multiply the numerator and the denominator here by 2 over 2. This 2 and this 2 divide out, and we're left with negative square root of 2 plus the square root of 2, all divided by 4. And remember what we did last time? We took this 4 out of the radical. That's the last thing that we would do here as well. And we have the second of our 3 computations. The last of these computations works exactly the same way. So we would consider what would have to be in the numerator here to determine what a is, and we would just double this. So tangent of 225 degrees divided by 2 is the same as the tangent of 112.5 degrees. So that means our a value is 225 degrees. Let's use our formula. This formula is tangent of alpha over 2 is equal to plus or minus the square root of 1 minus the cosine of alpha over 1 plus the cosine of alpha. Okay, so we're going to replace all of our alphas with 225 degrees. And we would then simplify this to be 112.5 degrees. All right, next thing, decide the sign, S-I-G-N, okay? Think about where this angle is. 112.5 degrees is in quadrant 2. Tangent in quadrant 2 is negative. All right, so this is going to be negative from now on. How about the cosine of 225 degrees? Hopefully you said negative square root of 2 over 2. So this is what we're looking at. We got the negative. We got the negative square root of 2 over 2 in both of these spots. We're going to clean it up a little bit by making this negative negative a positive and making the 1 into 2 over 2 so we can combine those things. Okay, looking good so far. So now what are we going to do? We're going to combine these two fractions in the numerator into a single fraction, and same for the denominator. Sounds good to me. Now notice that I have a denominator of 2 in both the numerator and the denominator here, so we'll multiply that by 2 over 2, and that will get rid of both of these denominators. And we end up with square root of 2 plus the square root of 2 over 2 minus the square root of 2. Now this does simplify a little bit further if you were to rationalize. I'm okay with you leaving it right here as long as the radical doesn't have any fractions within fractions. All right, and that's where we will leave this as a mission accomplished. We have found all 3 pieces. See you next time.